Hi everyone. In this video, I'd like to show you where law of cosines comes from and tell you a little bit of the general info about it. So we start in a similar place to law of sines where we have an oblique triangle, and we're going to assume that we know the values of side length B, side length C, and angle alpha. Hold on, I picked a not very good pen to get started with. Okay, and we would like to find the value of side length A. So the trouble right off the bat is that we don't have a right triangle, so we can't use any of our right triangle stuff. No Pythagorean theorem, no SOHCAHTOA definitions. So we start off just like before by cutting this into two right triangles. We drop a perpendicular with length h. H is an unknown, so it's not the one we're looking for, but h and gamma and beta would all be unknowns. And then what we want to do is see what the Pythagorean theorem can tell us about oblique triangles. So our goal is to look at each triangle separately and set up a Pythagorean theorem. But we run into some trouble with this one. It seems like not a great idea at first because this is our unknown that we're looking for, A. H is an unknown that we're not looking for, and I don't even have a label yet for this side length. So it looks kind of like a rough way to start, but we're going to go with it for a little while and see if we can build something useful. So I've already labeled this for you, but what you do is you choose either side, it doesn't matter, and you label it X, so either the base of the left or right hand right triangles. If I make the left-hand triangle have a base of x, then this one will have a base of b minus x, since we know the whole length of the top is b. Which means the Pythagorean theorem tells us that a squared is equal to h squared plus b minus x squared. So there's one of the triangles, and I'll come back in a minute to the h squared equals. The other triangle, the hypotenuse is c, that's across from the right angle, so we can say c squared is equal to h squared plus x squared. Okay, so if we look back at the things we knew and we didn't know, knowns, let's see. B is something that we know, and C is something that we know. A is the unknown that we're looking for. H and X are both just kind of junk variables for us. We don't know their values. That's not given information, and we're not looking for their values. So we'd really like to eliminate both H and X. We should be able to do that. We've got two equations to work with. So the first thing I'm going to do is go ahead and just solve both for H squared. So H squared is equal to A squared plus b minus x, minus, if I can get my sign right, minus b minus x squared. So we would subtract b minus x squared over with the a. And in this one, we could say h squared is equal to c squared minus x squared. And if we've done that, if h squared is equal to the first thing and the second thing, we should be able to set those two expressions equal to each other. So we should at this point be able to say that a squared minus b minus x squared is equal to c squared minus x squared. And I'm going to work on this algebraically a little bit. So I've gotten rid of h. I still have x's in the mix. So if I FOIL this first one out, b minus x times b minus x would be a b squared minus a 2bx plus an x squared. And then I can distribute the minus sign through. So a squared minus b squared plus 2bx minus x squared equals c squared minus x squared. And the x squareds drop out. So this actually doesn't completely fix the problem, but it does help. So no more x squareds. And I'm looking for a squared, so I'm going to go ahead and rewrite this so that a squared's by itself again. So I'm going to say add the b squared to both sides. I have b squared plus the c squared, and then I'm subtracting 2bx from both sides. Okay, so this is starting to, look pretty good. There it is. but I still have that x. So if I look at what I've got going on here, let's see, the thing that I want to know is the a, so I have that over here. I already am assuming that I know the value of b and c, so the only thing over here that I don't know is the x. That's the only thing right now that's giving me trouble. So let's go back and look at our triangles again. Looking at this one, this is the triangle that includes side length x. I know angle alpha and side length c. That's enough information for me to solve for x. So if I look at this from angle alpha, x is adjacent, c is hypotenuse. So I should use a cosine, and that's where the cosine comes into play. I might have lost my regular pen. So cosine of alpha is going to be adjacent x over hypotenuse c, which means that x is equal to c times cosine of alpha. And again, if we pay attention, c is one of the sides we know, and alpha is the angle we know. So this now gives us complete information about x. X is now a known thing. So if we go back to our formula, we can say that a squared is equal to b squared plus c squared minus 2b, and then we're going to replace x with c times cosine alpha. So this is one version of law of cosines, and the other versions are really the same thing, just with the idea in mind that you don't have to label sides A, B, C in a specific way. So I decided to make alpha the bottom corner, but what if I wanted alpha to be the bottom right hand corner or the top corner? That's all legal, so we don't want to be too tied down that it has to be alpha A. We want it to be able to be beta B or gamma C. So I'm going to write down the other two versions for you, but I just want to say that for the test, I will provide you with one version. I'll put one version on your formula sheet, and you have to be comfortable enough with the similarities to be able to figure out the other two. I think that's pretty easy, but I'll walk you through it right now. Okay, so if instead we wanted to get b squared by itself, I would say super key important thing to realize is that we have an opposite pairs thing going on here. Whatever side is over here by itself, the angle that's getting plugged into cosine is always the angle opposite that. So if this is going to be b squared, we're definitely going to end with a cosine beta. And then also, if you look at this, what we have is basically we've started with Pythagorean theorem. So this is what Pythagorean theorem tells us about oblique triangles. And the way I look at this is it looks a lot like a Pythagorean theorem, again, ignoring which letters are on which side, with a correction for the fact that it's not a right triangle. So if this is going to have b squared by itself, then I need information about a and c in all that first stuff. So it's going to be an a squared plus c squared minus 2ac cosine beta. And again, really pay attention. This is what determines generally which version you want to use, is which angle you have. So if you have an angle beta, you have to choose the version that has b by itself. And then the last one would be if I want it solved for c squared, then that would be in terms of a squared plus b squared minus 2ab, so all a's and b's. And then it would be cosine of gamma. Once again, you have to get that opposite pair. So that's the three versions of law of cosines. Like I said, on tests, I will give you one of those versions, and you have to be comfortable enough to reproduce any of the others. Okay, so we use this to solve for a missing side. We were given, here, let's go back up and look. We were given side angle side, and we showed that we could solve for the remaining side. That's not the only way to use this, so that is one way. And it's a nice one because that was not on our list before. So side angle side was not something that law of sines would help with, but it is something that law of cosines will help with. The other thing that's new is it also works on side, side, side. That was not okay for law of sines, but that is for law of cosines. And then angle side, side is one that we can already use law of sines for, but it can be tricky because we can get the no triangle or the two triangle situation, the ambiguous case. So this blurb right here is just pointing out that if you use law of cosines and you have the ambiguous case, it will be a little harder to solve. Not impossible, but messy. It ends up being a quadratic that you use the quadratic formula on. But I think it's worth doing that little bit messier work, because if you use law of cosines and you solve that quadratic, if that quadratic has two answers, that's giving you two possible side lengths for part of your triangle. So it's telling you that there are two triangles. And if there's no triangle, you'll get no solution from that quadratic. And if there's one triangle, you'll get one solution. So even if it is a little algebraically messier, it's really nice in that it doesn't leave you guessing about the ambiguous case. I think my only other comment here is just to warn you that on a test, I might just let you use whatever method you think is good, but you should also be prepared for me to specify, especially for angle side side, whether I want you to use law of sines or law of cosines. So make sure as you're working on the law of cosine section that the first thing you use on every one of those homework problems is a law of cosines. If you're starting off with a law of sines, you might be costing yourself some practice. All right, thanks for watching.